This video will cover the topic of organometallic reagents. An organometallic compound is defined as a molecule that has a carbon-to-metal bond. In most of the reactions that we've seen up to this point, carbon acts as the electrophile because it's not very electronegative. However, metals are even less electronegative than carbon. Because of the large difference in electronegativity between these metals and carbon, they tend to form ionic bonds with one another. However, a metal like magnesium, with an electronegativity a bit closer to carbon, can form a very polar covalent bond. Because magnesium is significantly less electronegative than carbon, the bond polarity points in the direction of carbon, giving the carbon a partial negative charge. This can allow carbon to act as a nucleophile. We saw something similar last semester when we talked about acetylide ions. Acetylide ions also feature carbon acting as a nucleophile. Remember that deprotonating alkynes requires a very strong base. Typically we use sodium amide. Alkanes are even weaker acids, so they require even stronger bases to deprotonate. There are two main classes of organometallic compounds. The first is called a Grignard reagent, in which the metal that allows carbon to act as a nucleophile is magnesium. The other type is called an organolithium reagent, where lithium is the metal that allows carbon to act as a nucleophile. Both of these reagents have a similar reactivity. Finally, let's look at how we synthesize these organometallic reagents. Grignard reagents are synthesized by mixing an alkyl halide, either a chloride, bromide, or iodide, with magnesium metal. Alkyl fluorides are not reactive enough to form a Grignard reagent. Typically, this reaction is carried out in diethyl ether. The ether, a polar but aprotic solvent, stabilizes the Grignard reagent that is formed. The structure of a Grignard reagent looks like this, where R, the carbon, is the nucleophile and has a partial negative charge. A partial negative charge is also carried on the halide, while the metal, magnesium, carries a partial positive charge. In addition to being a very good nucleophile, a Grignard reagent is also a very strong base, meaning we can't have anything protic around, like water or alcohols. Let's look at an example reaction. If we treat this alkyl bromide with magnesium metal in diethyl ether, we get this Grignard reagent, where the carbon next to the magnesium is the nucleophilic atom. Finally, let's look at how we synthesize an organolithium reagent. Organolithium reagents are synthesized by mixing an alkyl halide, either a chloride, bromide, or iodide, with lithium metal. This reaction is typically carried out in hexanes, another aprotic solvent. The product is the organolithium reagent, along with the lithium halide salt. Again, due to the low electronegativity of lithium, a partial negative charge is carried on the carbon. And again, the carbon is the nucleophile. Now let's look at an example. If we mix this alkyl halide with lithium metal in hexanes, we get the organolithium reagent and the lithium chloride salt. Again, it is the carbon next to lithium that is nucleophilic.